Now we discussed populations and we discussed communities. Now we're moving on to the next level, which is the ecosystem. The ecosystem is all of the organisms in a community and the non-living environment they live with and interact with. So when we're talking about not only the animals and the plants and the bacteria and the fungi, we're talking about where they live, how they utilize the area they live in, the geography, the topography, the water features, and so forth. One thing we need to keep track of in an ecosystem is that energy moves from the producers to the consumers, through the consumers, okay? And then chemical cycling is the transfer of materials within the ecosystem. So we're talking about not only the living things, but also the non-living parts of the environment, okay? One thing to talk about in terms of ecosystems is about the production. Okay, the primary production is how much solar energy is changed to chemical energy by the producers, and this is related to the area and the time period. And when we talk about the amount of living material in an ecosystem, we call that the biomass. And those are just some terms we'll refer back to over and over again. So we have lots of different types of ecosystems here. And again, when we're looking at the world net primary productivity, we're talking about we have a lot of primary productivity in the ocean and the rainforest and the temperate forests, less in some of the others and so forth. And so the oceans and the rainforest and the temperate forests contribute most greatly to the net primary productivity of the earth than a lot of the other smaller types of ecosystems do. Okay, when we look at the energy supply, again, the energy supply is going to limit the food chains. And so when we look at this, we think about it in terms of pyramids. We've got pyramids of production, which shows how the energy flows from the producers to the primary and secondary consumers in the high trophic levels. And when you think about the movement of energy, what you need to realize is that really only about 10% on average of the energy of each trophic level is available to the next level. So where does the energy go? Well, of course, the energy is used by the organism that stores the energy within it. For instance, here we have the producers, the flowers, okay? That energy is used by the flowers for their life processes. Some of that energy can be passed on to the grasshopper that eats the flower, but a thing that you need to realize is that some of that's also released as heat. Same thing when the mouse eats the grasshopper. Again, only about 10% of the energy that the grasshopper got from the flower is going to be available to pass on to the mouse that eats it. And so the energy is used in the life processes. Some of it is lost as heat, but it stays within, it cycles through the ecosystem. So when we eat grain or fruit, of course, we're primary consumers. We're eating the plants. When we eat beef or meat from other herbivores, then we're secondary consumers. If we eat fish like trout or salmon, then we're going to be tertiary, even quaternary consumers. We're not always on the top of the food chain. It just depends on what we're eating, okay? Only about 10% of all that chemical energy is passed on to the next higher level. So the thing that we need to realize as the human population is that we have about 10 times more energy available to it when we eat plants instead of the meat of herbivores. Okay, much less of that much less of the energy available is available in that secondary level, and even less in the tertiary level. Also, don't forget about the decomposers. This is really important because the decomposers are going to take some of those the leftover things, the things that are present after organisms die, and recycling those nutrients back into smaller compounds that can be utilized again by the producers to make their tissues. Okay. Another thing we need to think about in our ecosystem is the biogeochemical cycles, the various cycles like the water cycle and the nitrogen and carbon and so forth. Okay. Remember that we've got a continual supply of energy from the sun and from Earth's interior as well, but we don't have any resources of there are any sources of chemical elements except what we have on Earth. And so we've got to recycle those chemicals because all of the chemicals that we have are the only ones we ever have had, and we don't have any source of getting new ones from any other source away from the Earth. Okay? And so all of these things are really important in recycling the materials that we have here on Earth. They're all in all of these cycles. We talk about several different ones. We've got carbon, phosphorus, nitrogen, water, and oxygen. All of those things are involving several different parts. We have living components, we have non-living components there, and then we have various reservoirs. That's basically where the chemical is stockpiled outside of the living things within the ecosystem. We can talk about local cycles, just within our general area nearby, and there are also global cycles, like the water cycle would definitely be a global cycle rather than a local one. Okay, one of the main ones we talk about with living things is the carbon cycle, because carbon is, after all, the major ingredient for all organic molecules, which is what living things are made of. And we find carbon in the atmosphere, we find it in fossil fuels like oil and gas, we find it in dissolved compounds in the ocean, lots of things like that. And returning that carbon dioxide to the atmosphere basically balances what's removed by plants for photosynthesis. And so it's really important that we look at how that carbon is cycled. It's also affected by burning wood and fossil fuels, because that's going to return more carbon to the atmosphere from a place that it was stockpiled earlier. This diagram shows us generally the different interactions that are involved in the carbon cycle. We've got photosynthesis, which removes carbon dioxide from the atmosphere and makes food for the plants and for the animals. Okay, the primary consumers eat the plants. The algae and the cyanobacteria also are part of the producer level there. The primary consumers, like this rabbit here, are going to eat the carbon. They're going to some of it is going to pass on to their consumers, their predators. Some of it is also returned as detritus and as a result of waste material and death back to be recycled in the soil by microbes. Okay, we've got all of these things are also going to perform cellular respiration and return some carbon dioxide to the atmosphere that way. Okay, then we've got also the addition of wood and fossil fuel burning that returns some of that carbon to the atmosphere. So we have a cycle here where where plants remove carbon dioxide and return some of it, and other animals and other organisms can return most of the carbon dioxide back to the atmosphere. The phosphorus cycle is also an important thing to think of. All organisms require phosphorus because it's necessary for nucleic acid, for phospholipids, for ATP, which is our main source of energy. And so we have a lot of use for phosphorus as one of our required nutrients. The only source of phosphorus for terrestrial ecosystems is actually from rocks. Okay. The plants absorb phosphate ions in the soil. They use them to make the various kinds of organic compounds, and then the phosphates get returned to the soil by decomposers. In aquatic ecosystems, phosphate levels are pretty low, just because of the characteristics of those systems, and actually phosphorus ends up being a limiting factor in a lot of aquatic systems. Okay, so we have here phosphorus comes from the weathering rock. It's washed into the water by runoff. It's reassimilated into the soil and used by plants, which then provide it to animals, which then gets recycled back in the soil again. The nitrogen cycle. The nitrogen is also an important ingredient of nucleic acids and proteins. We've got to have it. It has to be present for the living things to function the way they need to function. Okay, and it's also one of those crucial and often limiting nutrients for plants. There are two abiotic reservoirs of nitrogen. The atmosphere, of course, which is about 70 to 80% nitrogen gas, okay? And then the other source is the soil, okay? Nitrogen fixation is the process that nitrogen in the atmosphere is converted to compounds of nitrogen that plants and animals can use. Because animals, and no organisms really can use nitrogen straight from the air except for certain soil bacteria. And so nitrogen fixation is a really important process that provides nitrogen for organisms to use. We have various kinds of nitrogen fixing bacteria that are found in root nodules, some of others that live in the soil. They can utilize nitrogen directly from the atmosphere, change it into compounds like ammonium and nitrates. The nitrates and ammonium can be used by various other soil bacteria and provide nutrients for plants. The plants assimilate the nitrates into their tissues that are then eaten by animals, and then those things are returned to the soil by means of the detritus and the decomposers, the detritivores and the decomposers. There are also denitrifying bacteria that can return some of that nitrogen to the air as well.